Hello everyone, my name is Mohan Zhang, and my topic today is model pruning on low complexity architecture machine learning models. And before we going on, let's start with some background and innovations. Let's start with artificial intelligence. Artificial intelligence has become a really popular topic in our current lives, and it really changed our way of life. It has been well used in many different areas, for example, like medical diagnosis, the natural language processing, and as well as automatic vehicles. Then we've been wondering how that actually happens, how that actually works. Here we come to the machine learning. Machine learning is the basic algorithm behind the AI, and machine learning is a technique to allow the computer to learn from data and make decisions or predictions. Let's look at the graph. We have some vegetables with labels as carrots, tomatoes, and bell peppers. We put in these labels and also the data into the model. The model will train itself and learn from the data to make predictions. And next time, when we pass in some test data without labels, it can tell us which one is which. It's no much different than training a child. And after that, we need to evaluate the performance of the machine learning models. The most important word is accuracy. Accuracy shows how well the machine learning model can predict or make decisions. The accuracy should be high enough for us to trust the machine learning models. And if the accuracy is too low, let's say below 50%, it will be no better than toss a coin, which means the model is useless. And people are trying to increase the accuracy of the machine learning models, and we can apply the more complicated the algorithm in the calculation into the system, and that will increase the parameter amount and as well as the complexity of the model, thus increase the running time and model size. That really causes a problem. Let's say we have a really big model which has a really high accuracies. It will require high computational resources, and it limited the possibility of applying this model onto the portable device like smartphones, smartwatch, and as well as laptops. Then what can we do? We can apply the model compressions on the original models, and it can reduce the model size, meanwhile to keep the high accuracies. And these are the commonly used technique in the model compressions, like pruning, data quantizations, parameter sharing, and as well as knowledge distributions. And technique like pruning and data quantizations has already become industry standard in the model compressions. And our topic is trying to apply the pruning on small models. Traditionally, the pruning is only used for the large models because in the large machine learning models, many parameters of connection are redundant and have very little contribution to the final model performance. And we are trying to see what happens on small models. We choose S4D as a low complexity architecture machine learning models, which is used to analyze the ECG of the patient to diagnose is there any cardiovascular disease or not. Here's our approach. Firstly, we plot the width distribution graph, and we apply the prunings on different layers. And finally, we evaluate the accuracy and the change in model size. During this process, we are applying fine-tuning to make sure the best performance. First, the width distribution graph. It shows how the weight in a model are spread out. And if a parameter has a really low weight, it will show as a 0 in the axis in the graph. And after that, we are applying the pruning on each of the layers. The graph shows the weight distribution graph after the pruning rate of 0.3, which means after the pruning process, only 70% of the parameters will remain and all the other will prune out. And finally, we are doing the evaluation and fine-tuning. In the evaluation, we are trying to reduce the model size by cut the parameters, but we probably cut some important parameters or connections which have a significantly influence on the accuracy drop. So we need to balance both model size and also the accuracy. So we have fine-tuning. During the fine-tuning process, we can use different importance calculation methods. And during the pruning process, we are cutting the parameters with low importance. And the importance can be calculated in L1 norm, L2 norm, and also other algorithms like LP norm. And after that, we can also try to pruning the model for different layers. As some of the layers maybe have a major influence on the final performance, and some of them may only have a minor importance. And lastly, here's our conclusion. We are trying to evaluate the feasibility of applying pruning on low complexity machine learning models. And if that works, we can reduce computational requirement and also increase the calculation speed. And finally, we can apply the model on the portable device. Here is the reference, and thank you.